This is the diagram here. You have something like this. Are we saying it? This is your 3 microfarad. This is your 3 microfarad, and this is what? This is 1.5 microfarad. Now, if I were you, I'll first treat this. I'll say this is section A, and I'll now say this is section B. So for section A now, 1 over C equals 1 over 3 plus 1 over 3. Why? Are we permitted to do that? No. Why? Because this is parallel connection. For parallel connection, you are permitted to add your what? C total as C1 plus what? C2. This is C2, this is C1. So from there, my C total will become 3 plus 3. That's what? 6 microfarad. You understand? So if I now have that, note that your C total and what? B are what? Are also in parallel. So therefore, you can say my C total now, my C total is not everything. You have C total. The C total will now be 6 microfarad plus what? 1.5 microfarad. From there you have a 7.5 microfarad. Hope you are getting it. So it's as easy as that. Third question says calculate the energy stored in a capacitor if capacitance to 20 microfarad. You understand? The capacitance of their capacitor is 20 microfarad. Now, if the potential difference between the plate is 40, of course, you know that is very, very easy and it's very much simpler. Here we are going to be looking at electric field 2. That's the second series or the second section. You know, we started with electric field. So this is the second series. So in our electric field 2, we're looking at current electricity. Current electricity. We're going to start with electric current. Mind you, the topic is current electricity under is a subtopic under the electric field 2. So under our electric current, now what is a current? A current is any motion of charge from one point to another in a conducting material. Any experience of charge, you understand? Any discovery of charge in a conducting material flowing from one point, let's say this point A to point B. You understand? Now, if this particular material flowing are current, you understand? Or if they are charged, let me see, if they are all charges. Now these charges are being detected that they are flowing from here to here. Definitely you see that that particular charge that is moving from one point to another is called current. Hope you can see. That's the major analysis of what current actually means. Is any charge that is being experienced that is moving from one point to another in a particular conducting material. Now if we proceed, we said with a speed of about 10 exponential 6 meters per second, that is, it has a speed of 10 exponential 6 meters per second. If you break this down to give you something like this, that's 10 million meters per second. Now it means that for every 1 second, each charge moves this particular distance, moves as far as 10 million miles as a distance. Do you understand? 10 million meters. That's 10 million meters for every charge you see in every conducting material. That's the average speed of that charge. Now, and hence there is no net flow of charge. Now, current is denoted by I. You understand? If you say, you know, we are looking at current now. The actual notation for current is denoted by what? I. Do you understand? And it has an SI unit. Current has an SI unit of what? Ampere. Some people call it amps. The short word is what? Amps. You understand? But if you are an engineer, amps is always used by layman, people that all these roadside mechanics or engineers. But if you want to be an engineer, you must describe the SI unit of what? Your current. It is what? Ampere. You understand? And the short form of ampere is what? E. So you get. So for every of current descriptive properties you are doing, you must always what? fits in the what? The SI unit. If I'm to write quantify current now, if I'm say okay, the current that is actually moved is 3, what will you say? 3 amps. These 3 amps makes it look that, makes it appear that what you're actually describing is what? Current. Do you understand? So that should be the SI unit. Now, another thing we should notice that current is noted by I. So we've spoken about that. It is the direction in which there is a flow of positive charge. You understand? And thus, current are described as if it consists entirely of a positive charge flow. Naturally, they're supposed to be, you want to write current now, it has E minus. Do you understand? Whether it's being placed here or here. You understand? It has a negative charge. Do you understand? Now, irrespective of the charge, it doesn't affect the movement. It can go this way, it can come this way, it can go upward, it can go. You understand? So, meaning that the movement, you understand, the charge at which the charges that all the charges that are being experienced here, irrespective of what they are, the charge on it. This is a negatively charged electron. It doesn't affect the direction of movement. Whether it moves towards this side or it moves towards this side, it never affected the direction. Now, if we should go by that word, it means that if you have a negatively charged electron in any particular conducting material, whichever direction it moves, you understand? Whichever direction it wishes to move, it's going to move without what? Without considering the charge. That's what that statement actually meant. Now let's proceed. In another word, you can say a coulomb. We spoke about coulomb. Coulomb is just coulomb is a measurement given to what? Electronic charges. You understand? The measurement of what? Electronic charges. Why current is what the equation of these charges. Quantity of charge gives you coulomb. You understand? That's your Q. Now, when you now say electric current is now the accumulation of those charges. You understand? The display of those charges in a particular electric field is what we call current. If you go back to our definition, it said it is any point of charge. Sorry. If you go back to the definition, he spoke about, he said a current is any motion. You understand? Any motion of charge from one point to another. Now, when you have a charge that moves from a point to another, you understand? That movement of that charge from one point to another makes that charge a current. Hope you are getting it. But when you have a charge in a particular place, when they have been accumulated, you understand? It's no more what a charge, but what? It's no more a current, but what? But what? That's your quantity, that's your coulomb. You understand? That's your Q. It's called quantity of charge. So when you have accumulation of charges at a particular place, it becomes Q. That's quantity of charge. But when you have those individual charges moving from one point to another, it becomes what? Current. Hope we are getting it now. So our coulomb, which is quantity of charge, can be equal to what? Can be equal to your T. Your I. T. Where your I equals to what? Your current. And your T equals to your what? Time. Your current is measured in amps. Your current is measured in what? Seconds. Hope we are getting it now. So it means that if we must obtain our current from here, you just make I subject of formula. So your I will become Q over what? Over T. Where your Q is measured in coulomb. So your SI unit of current could be coulomb per second. You understand? We said SI unit for current is what? Amps. So you can also use it as what? Coulomb per second or what? Amps. So those are the little breakdown when it comes to what? Current electricity. Now let's go to another very good term. Electromotive force. Electromotive force. Electromotive force, we call it what? EMF. You understand? Scientifically, we call it what? EMF. You used to hear, what's the EMF of that what? Metallic wire. You understand? You have to know what EMF actually means. Now, a statement says, for a conductor to have a steady current, it must be a path that forms a closed loop or a what? Complete circle. I hope you are getting it. Now, the EMF is defined as the magnitude of the potential difference of what? Both the external circuit and the internal structure of the cell. Both the external circuit and the internal structure of the cell. It is defined as the magnitude of potential difference. So your EMF too is potential difference. That's voltage. We call it PD. Here you are getting it. So the magnitude of the potential difference of both the external circuit and the what? And inside the cell or the internal circuit. If I have a circuit like this, let's assume what I have here is what? Resistance. Now I now have your what? Ammeter here. I now have your cell here. Shall you understand? I now have my key. You know, there's what we call key. It's a closed circuit now. Now, if this is to be my what? Where the pole PD is measured, that's potential difference. This is my resistance. This is my what? Ammeter. Right? Now, this is what I call switch or key. Now, if you look at the circuit very well, for you to actually what? Relate that definition with this circuit, it means that it is the magnitude of what? Potential difference in this circuit. You understand? I mean, at the outward of this circuit and the total of potential difference at the internal structure of this circuit. So, if you look at it properly now, so EMF is what? Total. You write total or magnitude. You still use your total sharp. Total or magnitude of what? Of what? Potential difference across, listen, across the internal structure of circuit and the external. So the EMF experienced both inside the circuit and outside the circuit, calculation of the two makes us discover what? I mean, makes us to form what? Or to have what? EMF. That's the electromotive force. Let's proceed. Now, the potential difference between any 2 points in a circuit is the work done when one column of a charge moves from one point to another. We normally hear of EMF. We also normally hear of potential difference. This question is always surfacing in WAEC or NECO. You understand? You'll be told to differentiate between EMF and potential difference. Now, if we will proceed, what is EMF? From our definition, then we'll discover that EMF is the magnitude of potential difference. EMF is a potential difference. Hope we know that. But there are different in such a way that EMF is when you sum total. The total what? I mean, when you